right? So in the 2D shape and in a 3D shape, the difference is only of height. 2D
Hmm.
shapes only have got two dimensions, that is length and breadth, while 3D shapes will have three dimensions, length,
Hmm.
breadth, and height as well.
Height.
Getting it,
Yes.
guys? Okay,
Hmm.
so that is the thing here. Okay, so here you can see figures like triangle, okay,
Hmm.
square, rectangle, and a simple circle. None of them have got any thickness. They are simply 2D figures here. Getting it here?
Yes. Hmm.
Okay, so we see that a shape with only two dimensions, such as length and width, and no thickness, is called a two-dimensional shapes. For
Hmm.
example, squares, circles, triangles, etc. These are two-dimensional shapes. Getting it?
Yes.
Okay. Then you have examples of 3D figures. So in 3D figures, what do you see? That a figure has got some amount of thickness in there.
Height. Yes.
Basically, it is thickness due to their height. Good. Okay. So whether you have got cuboid or cube, these are the figures that have got some amount of thickness, right? So they are
Yes.
called 3D shapes. Or D here basically stands for dimension.
Dimension.
Dimension basically, in a general way, it basically refers to their lengths, their measurement, the measurement
Hmm.
of the length, right? Okay. Then let's have a look at the view of 3D shape. How does a 3D shape look like? Hmm.
Hmm.
So all the solid shapes which you see in the nature, they have got a 3D shape, right?
Hmm.
Not all of them. They might have 4D shapes, 5D shapes as well. But usually
Yes.
solid shapes around our homes, in our homes, you will see they are of 3D shapes.
Hmm.
Okay.
Yeah.
So from different sides, their appearance varies. Like you must have seen
Hmm.
in so many museums or in art places that artists make 3D objects in such a way that if you look at a specific angle, the object appears to be something else. While if you look at the object at a different angle, it appears to be something else. Huh?
Hmm. It's I saw it.
Yeah. So for example, they
Yes.
have got a art piece like from a particular angle, no, it looks like a dog. Okay, it looks
Hmm.
like a dog here.
Yes.
Okay, but from another view, if you were to view from here, from front view, it looks like a dog. But on the another view, it looks like a leopard or lion or something else.
Hmm.
So
Yes.
the perception changes here, right?
Yeah.
Okay. For example, you have got this staircase here. Hmm.
Hmm.
What is the front view of this staircase going to be? This is the front view. No, no.
Yes.
If you were to be standing
Hmm.
on top of it, basically the the surface on which you are standing, that is going to be its top.
Hmm.
Okay,
We
and if
will view
hmm,
rectangles or square base, cube based on
mhm.
the
And
figure.
if you are standing on its side, this is going to be the side view, right?
Yes.
Okay,
Hmm.
okay, okay. And okay, is there any some background noise coming from my side, guys? If there's any, please
No.
do tell me. No?
Yes.
No, sir.
Yes, sir.
No.
Okay. See, what if you were to draw the this 3D shape here in a piece of paper? So it is going to look like this. You have basically
Hmm.
um, yeah, drawn the top view like this here, this top view.
Hmm.
I know this these top views we have drawn over here. Then the frontal view it's going to be
Yes.
like this. Getting it?
Hmm.
And the side view is going to look somewhat like this. So
Yes.
shortest view of the 3D picture, it is being depicted by the side view over here, right?
Hmm.
So when we draw the top view, front view, and side view on paper, it will look like this. Okay, just give me a moment, guys. Okay, I will be
Yes.
back in a moment. Okay, there's some
Hmm.
background noise from my side. Let me get it. Um, okay. Yeah, sorry sorry about the interruption.
Hmm.
Okay, so you have one example of a dice here. Okay, look at the top side and front view of this dice. Okay,
Yes.
all right. Now, if you were to represent it on a piece of paper, the front view it's going to be looking like this. There are three dots over it. Side view like this,
Hmm.
and top view like this. That is quite simple here. Okay.
Yes.
Some important points related to map, right? So,
Hmm.
a map is basically a 2D representation. Nowadays, we have got 3D representation of maps as
Hmm.
well, right? So, in 2D maps, you
Yes.
see different objects or places. To represent them, different symbols are used, right?
Yeah.
Okay,
Hmm.
so for example, to represent a road, a symbol like this is used. Straight lines are used
Yes.
to
Hmm.
represent roads, railways, rail lines, basically, or water
Yes.
canals or rivers, right? So this type of
Hmm.
symbol will be used. For example,
Yeah.
here you will see there are different routes connecting to the Nehru Road here are
Hmm.
depicted here, right? And
Yes.
then you see different shapes, different symbols have been used to represent different physical features here. For example, lake,
Hmm.
this lake here, water plant here, city colleges, locality. So this is a depiction in which basically you will see roads are given here. Road A, Sastri Road, no, then the
Hmm.
road D, right? So all the
Hmm.
roads connecting to the Nehru Road is given here. Roads that
Yes.
connect to Nehru Road, it's given here. See, this is Nehru Road is a junction of all the roads right here.
Yes.
Okay.
Hmm.
So in a map, you don't get the actual size of the physical features on the land. Okay.
Yes.
So you get a relative picture here. You get a representative picture. So a map represents
Hmm.
everything proportional to their actual size, not on the basis of perspective. Right.
Hmm.
So for example,
Yeah.
on a piece of map, 1 centimeter might represent 1 kilometer on ground.
Hmm.
I know. So for example, you get a map of India. Okay. Now the
Hmm.
north, south, and east and west dimensions of the India are given. All right. So
Yes.
this is your India. Basically, somewhat it looks like this. Getting it?
Hmm.
Okay, suppose it's
Yeah.
India, right? So the distance from here to here it's given. Suppose 3,341. That is the distance of
Hmm.
east and west frontier of India, and the north and south
Yes.
is 2,933 kilometer. Okay, so it's
Hmm.
practically impossible to cover this much of distance in a piece of small paper.
Paper.
So, in
Hmm.
order to do that, we take help of small scales. Right. So, 1 centimeter
Hmm.
will be representing this much of kilometer, for example. 1 centimeter might be representing only 1 kilometer on ground or 10 kilometer on ground based on the size of the physical feature we are trying to represent on the map. Okay.
Yes.
So a particular scale is used to draw a map so that lengths down are proportional with respect to the size of the original figures.
Hmm.
Hope that is clear now. Hmm.
Yes.
Okay. Talking about area. So you guys are already familiar what are area. Area is basically
Yeah.
measurement of space enclosed by a figure. It could be
Hmm.
any figure. Okay.
Yes.
Then talking about a 3D figure, particularly the point of our discussion is going to be 3D figure here, especially. So, what
Hmm.
are the features which we observe in a 3D figure? Hmm?
Yes.
So, first,
Um.
before we even talk about that, for
Mhm.
example, if I were to give you a 2D figure, if I were to give you a piece of A4 sheets, I know, and I ask you, I'm not giving you only one sheet of paper. I have basically given you a
Hmm.
bundle of, let's say, 500 A4 sheet paper, and I ask you to convert this 2D figure into a 3D figure. So, how would you guys do that? Hmm?
Um.
Or let's say if I were to provide you with just circular plates here, circular plates, and I ask you to
Okay.
convert this circular plate into a 3D figure, how do you do that?
By stacking it one on top of the other.
Exactly. You will
Hmm.
basically start placing circle plates one over another, right? So
Yes.
that basically gives you the component height here as well, right, guys?
Hmm.
Okay, so you get the height here. So in the same manner, you will basically stack A4 sheets paper one over another. So that will basically give you a 3D figure now.
Hmm.
Getting it, guys?
Yes.
Hmm. So that is the thing over here. Okay. Now take a look at this 3D figure here. What are the components which we usually find in a 3D figure? So the junction where all the three edges meet, that is simply called as vertex. You guys have been
Hmm.
studying about this in 2D figures as well.
Yes. Yeah.
These three are vertex. Getting it here. So usually if
Hmm.
you have got a figure like cube, how many vertices are going to be there?
1, 2, 3, 4, 5, 6, 7, 8.
8. I know.
Hmm.
Okay, then
Yeah.
edges are simply the sides. So how many edges are there in a
6.
cube? There are 6, not they are supposed to be more than 6 now. For the base, in the base they are going to be 4. 1, 2, 3, 4. Right?
Hmm.
So
Oh,
they are,
okay.
first see how many surfaces are there. 1, 2, 3, 4, 5, 6 surfaces are there.
Hmm.
Okay. Faces basically. 6 faces. Talking about the edges here. Okay. Take the curved surface area. So one here, one in the behind, and one in here.
Hmm.
So 4 edges are there. Okay, for these 4 edges here, and the 4 edges at the bottom. How many edges?
Yes.
Total 12.
8. Yeah,
4,
12.
4
Yeah.
above, 4 down. 8.
Hmm.
Okay. 2 of the front one, 2 of the back side. Getting it
Hmm.
here. So
Yes.
this these fours 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12. So there are 12
Yes.
edges. Right.
Ah.
Arhan, are you there or not? Arhan is here or not? Yeah.
Yes, sir, I am.
Okay. Okay. Hmm. Okay. So faces are the basically flat surfaces of the 3D shapes, or we can also say that faces are basically 2D shapes in here. No, we can also
Yes.
look at it like that. Then edges are the line segments which make the structure of the solid shapes, right?
Hmm.
Okay, and the two faces meet at the edges of the 3D shapes. What does it mean?
Yes.
Two faces.
And like,
Mhm.
yeah, they meet
This
at the
face,
edge.
yeah, this face here and this face
Hmm.
over here. They are meeting at
Yes.
this edge over here.
Yes.
I know.
Hmm.
And vertex, you guys know. Okay, and the plural of vertex is vertices. Know this thing. Okay.
Hmm.
Okay, and the next concept is polyhedrons. Now, what are the polyhedrons like now? Huh? Any idea?
No.
It is basically a solid in 3 dimensions with flat polygonal surfaces, and they have a straight edges and sharp corners or vertex.
Hmm.
For example, you have got a cuboid, you have got a cuboidal shape, you have got a pyramid shape. In this, you will
Hmm.
see the surfaces are flat, the edges are straight. Right now, so see in this
Hmm.
tetrahedron, that looks like the tetrahedron basically, which has got how
Yes.
many faces? 4 faces in here, right? So
Hmm.
here you will see that edges are sharp here. They are straight,
Yes.
straight edges. Okay. This cube and this octahedron also, you can see the edges are very straight, and the
Hmm.
corners, that is vertex, they are sharp.
Yes,
While
sir.
if you were to
Yeah.
have, contrary to these examples, if you were to have a cylinder, do you see the
Hmm.
edges are sharp here, or do you see the vertex are sharp here? Hmm? Or the
No.
edges are straight? No.
No.
Okay, so these are the polyhedrons. They have got a flat surface. They are made up of line segments. Okay, so the
Hmm.
3D shapes made up of polygons are called as polyhedrons. So polygons, you guys must have already studied about it. Arhan, please explain what is a polygon. What is a polygon? Basically, a 2D shape made up of
shape,
three or
more
more
than
than three
4
lines.
shape. Yes,
Three or more than three lines. For example, you have got
yes,
triangles, you have got quadrilaterals now, you have got pentagon, you have
hmm,
got hexagon, you have got heptagon, octagon, nonagon, decagon, and so on and on. Yeah,
yes,
Arhan and Arham. So they will be
yeah,
made up of polygons. And polygons, they have got straight lines in them. All the polygons have
yes,
got straight lines. All the polygons have got sharp
edges.
vertex, right?
Hmm.
Okay. Now, these solid shapes we already know faces, face, edges, and vertex. Now,
Hmm.
the polygons are the face of the solid shape. So, in this case, what is the face of this tetrahedron?
On the front.
It's a triangle,
Hmm.
right? In the case of
Yes,
cube, what is the face?
square.
Square. And in this octahedron, what is the face, Arhan?
Triangle.
Sir,
Triangle.
isobium.
No, not a rhizobium. Look at this. No, this is, yeah. Rhizobium is a different thing. Okay, rhizobium in which all the sides are equal, right? Opposite
Hmm.
angles are equal. That is rhizobium. Okay, and the plural of word polyhedron is polyhedral. Okay,
Hmm.
so
Yes.
this is the singular. This is the plural word of polyhedron. Now, shall we move ahead? Any confusion so far?
No.
Okay.
No, sir.
Now the question comes: what is a non-polyhedron now? Hmm? So what would be
This,
non-polyhedron? Seeing at the figures here.
with the shape that which have not that sharp vertices.
Hmm.
And
The solids which have basically curved faces are called as
yes.
non-polyhedrons, and their
Yeah.
edges might be or might not be straight. Okay,
Hmm.
so for example, see cylinder, cone, sphere, torus. In this, you will see that the faces are curved, faces are not straight, right?
Yes.
So in the first thing, we see that faces are curved. That basically means they are not polygons, right? Now
Yes.
faces are not polygons. So these will be basically non-polyhedron. Examples are mentioned here. Okay. Now, in the case of polyhedrons, you will see they are of two types. One is convex polyhedron, another one is concave polyhedron. Right.
Yes. Yeah.
See for this um, solid cuboid here. Okay. So in this, you see
Hmm.
the line segment formed by joining any two vertex. So see two vertex over here. Let's say this one, right?
Hmm.
This vertex
Yes.
and this vertex, guys, here.
Hmm.
Okay. So here you see if the line segment formed by joining any two vertices of the polyhedron lies inside the figure, then it is said
Hmm.
to be a convex polyhedron. Hmm. So let's join the two lines here, right? Let's join
Yes.
these two lines. Further, also we can join these two lines as well, right?
Yes.
These two joins, these two vertex can be joined, and so on and on.
Hmm.
So all of them will be lying inside the figure. So in that case, it will be called as convex polyhedrons,
Hmm.
right? Similarly, you have other examples as well. Okay, for
Yes.
example, a solid triangular prism, right? Take example of
Hmm.
a solid triangular prism as well. So in this case also, if
But
you were
we
to
can.
join the opposite vertex, they will be lying inside the figure.
Hmm.
Yeah.
Yes.
Any question?
No.
No, sir.
Okay. Okay. Now moving on, you have got non-convex or basically simply concave polyhedrons. Getting it?
Yes.
So if any one or more line segments formed by joining any two vertices of the polyhedron lie outside the figure, then it is said to be non-convex polyhedron. Now, what is the distinction
Yes.
between the two, guys? Okay.
When we draw a
Mhm.
line, the line is outside the figure.
Mm. So see for this figure number 2 over here. What can we conclude about this vertex and this vertex? If you were to draw a line between the two, this line,
Hmm.
is the line inside this
Yes.
figure or outside?
No, outside.
Outside the figure, no? While some
Hmm.
of the lines might seem to be inside, some of the lines are inside. For example, this line, no,
Yes.
this line. But there are exceptions here as well. Okay.
Hmm.
Okay. See figure number 1 over here. Here also, take these two vertex over here, this one and this one. The line again is
Yes.
lying outside the figure.
Yeah.
Getting it? So that is basically
Hmm.
concave. Yeah,
Polyhedron.
sorry, concave polyhedron. Right. Okay. Now, so that is it about the the solid shapes. Now further, we have classified the solid shapes here. Now further, we are going to study about each and every solid shapes in detail. Getting it? Okay. So now let's start our discussion from the solid cuboid. All right. So solid cuboid. Give some of the examples of solid cuboids looking at the things placed at your room. What are some of the examples of cuboid which you can quote as example? Mhm.
Cupboards
Yeah, right. Almiras,
and doors. Yes.
doors. Yeah, door can also be
Sir,
classified as a,
plant pot.
yeah, a cuboidal plant pot. Right.
Hmm.
These are no, but you see, now it has to be perfect cuboidal. But because plant pots can be like this as well, right? Looking like a
Yes.
looking like a trapezium.
Trapezium.
Yeah.
Hmm.
Okay. From the face of the plant pot might look like a trapezium, not the figure because it's a 3D figure. Hmm.
Sir,
So
a
what is a
helmet.
helmet?
No.
Helmet is usually of a hemisphere shape, no? Like this.
Yes.
We're talking about solid cuboid, no? Okay. So in a solid cuboid, basically the figure looks like this. No, the figure somewhat
Hmm.
looks like this. Okay. Arhan, you tell me what are the vertex here? Let me write the give name to it. Okay. Name two vertex in this figure. Mhm. Vertex. Arhan, you listening? Arham, you name few vertex in this figure.
A B
A, B, C, D, up to
D.
H. They are all vertex,
Yes.
right? Okay.
Hmm.
What is the width of the figure here?
Means I didn't understand you.
Width. Breadth, basically breadth.
Sir, sorry, sir, I had an internet problem.
Okay, no issue. Width here, this side BC here, right? That
Hmm.
is width. Side
Oh,
AD, that is also width.
A B
Side
A D.
EH, yeah,
Hmm.
ED, and then GF. These are all examples of width.
Yes.
Okay, what is the face? Give some example of the face in this one.
A B H G.
No, face. Okay, ABHG. Okay. Huh. That is example of face.
Sir, D, C,
Yes.
E, F.
DCEF, then
Sir,
ADFG,
sir, B, H, E, C.
BHEC. Exactly. So those are the faces given here. So how many faces are here?
Sir, 4.
No,
4. No,
no,
6.
no.
5. 6.
Six, guys.
6, sir, yes, sir.
Yes.
Six faces. The
Yes,
four,
sir.
basically, look at your room, the four walls, and the top, and the base.
And
That is
bottom.
six faces. Yeah.
Yes.
Okay. Vertex, that is going to be how much?
1, 2, 3, 4, 5, 6, 7, 8.
8 vertices are there.
Yes.
Okay. This is basically your length here. So that is simply a solid cuboid in here. Getting it?
Yes.
Okay. Now talking about finding its surface areas. How do we do that? Hmm? If you were to find the area of 4 faces or 4 walls in here, so what is it going to be?
The area side into side.
We are talking about 4 walls, no? Area of one face
Oh, 4 faces.
multiplied
Oh,
4. So area of one face, it's, let's say if it's
4,
A.
4, 4
Mhm.
A.
No, it's
No.
not 4A. Look, for this one, if you were to see, say that length here is A and breadth here is B. Okay, so in order to find the area of this one, this face, we are talking about face A, B, H, G. The area is going to be,
To the lateral surface area, right?
yeah, lateral surface area. Yeah. We are talking about lateral surface area, excluding the base and the top, right? So it is going to be length into breadth.
4A square.
No, that is wrong here.
Is this a cuboid?
Is it a cuboid? No, it's solid cuboid here,
Yeah. 2
right?
into height, length into breadth. Length plus breadth.
We are coming at that, but let's talk about its derivation. So the area of the front face, that is ABHT, is length into breadth, and there are 2 such faces now, one at the front side, one at the back side. So we will multiply it with 2, right? Okay, now look at the front one now. Okay, so here you will look at the height also, right? So breadth and okay, this one is going to be length, guys. Okay, and this one is going to be breadth.
Yes.
Length, breadth, and height. So let's take it to be A, L, and B. Getting it? Or simply not, let's take it to be length, breadth, and height. L, B, and H. That will be more appropriate, no? Okay, so let's say that, let me rewrite it. This is your length, this is your breadth, and this is your height. Okay, side BH, that is height. So here it's going to be length into breadth for this one. Now talking about the face BCEH. What is the area going to be? B into H, no? This breadth into height.
Yes.
They are basically this height will serve as its length here, base
Breadth
and
into
length
height.
here. Yeah, so it's going to be breadth and height. So how many figures are there? How many such faces are there? One at the front side, this one, and one at this one. No, not 4, only 2.
Yes.
2.
Yes, sir.
2. Then again, look at the top and bottom. Right. If this one is length, this one is also length over here, no?
Yes.
Right. And then this is here, breadth here. Right. This you will take it this one here as well, right? So here it will simply 2 multiplied L into height now.
Yes.
Getting it? So we will take 2 as common in all of them, so it becomes 2 into LB plus BH plus LH, guys. So that is the formula required to find the curves total surface area. In fact, here we have found area of 6 faces. The total surface area of a cuboidal shape is found out like this. Hope that is clear to both of you.
Yes.
Okay, and the volume, it is simple, length into breadth into height. That is volume, right?
So can I take
Okay,
screenshot?
yeah, you guys can take the screenshot. But you, before taking a screenshot, write one more thing. What if you were to just find the curved surface area, not the total surface area? Then it's going to be
height, length plus breadth.
2 into length
2h
into
L plus
breadth
B.
plus B into H. Or is that wrong? 2 into length into breadth plus length into height, no? Okay. So in this way, you can calculate it. Okay, take the screenshot, then we will move ahead.
It is.
You're done? Okay.
Yes.
Now let's talk about cube. It is in fact simpler than cuboid. Okay. So simply take few pieces of cardboard sheets. Okay, that are
Yes.
square. Take a square cardboard sheets. Six of them. Take 6 square cardboard sheets and basically join them by their edges. So you will get a
Yeah, we will
figure.
complete.
Yeah, you will get a cube here. And you guys already know that all the sides of a cube are equal,
Equal.
right? So let's say to be
Yes.
A, and A here. Getting it here.
Mm.
Okay. So basically all the things are going to remain same here. It will have same number of vertex, same number of width, same number of faces. Everything will be same, right? But its total surface area, okay, its curved surface area and its volume are going to be different, right,
Yes.
guys? So area of one side is A square, and since there are
Square.
6 faces in this one, 6 walls in this one, so it's going to be
6
6A square, and curved surface area is going to be 4A square now.
4 square.
Okay, 4 into A square. Okay, now talking about the volume, how do you find the volume of a cube?
A cube.
A cube simply, right? Okay, so that is also quite simple. Oh, no. Okay,
Yes.
then you have got complex. These were basically the what do you say? Um, Concave polyhedron, no, or convex polyhedron.
It's a convex.
Convex polyhedron we were talking about. Then you have got non-convex polyhedron, right? For example, you have got a cylinder. So how do you calculate the area, volume, the curved surface area, total surface area, and the volume of a cylinder over here?
The curved surface area will be.
Let's first understand this figure. Okay, so
Yes.
here, if you were to simply have a piece of circular plate and you were to stack one upon another, so you will be basically getting a cylinder shape, right? So this is
Yes.
the height, and this here basically the base. Okay, and it will be having a area as well. Okay, so it might be a hollow cylinder, or it might be having a base as well. Okay, so the it might be having the figure might be closed on both the sides, or it might be open on the both the sides depending upon the question. So it might be given. It will be given in the question. Getting it? Okay. So talking about the volume, right? So look for the volume of this figure here. How do you find the volume? Any idea? Okay, that is the formula. Okay, but how did we derive that? How would you find the volume of this figure?
As there is a circle, we will have a pi. As there are two circles, so we pi square. And there are also two circles means two radius and the height.
Okay, look here. The area of this simple circle, since it's lying on the flat, that's why it looks like this. Otherwise, it's like this. All right.
Yes.
Okay, so here you see the area of a circle, it's pi r square, right? But we have stacked circle after circle on top of each other. So you have got so many circles, right? So there comes a component called as height. So you simply multiply it with height now. So volume becomes pi r square h. That is the formula required to find volume. Getting it here? Now the question is that how do we find the curved surface area? How do you find the curved surface area of 2 pi r h? Okay, that is the lateral surface area as well, right? So it's going to be 2 pi r h here as well. Now the question comes that how did we got this 2 pi r h? Any idea?
The perimeter of a circle is 2 pi r.
Very good, very good.
And we will add an height.
Exactly, very good. So perimeter of the base of this cylinder here, that is going to be 2 pi r, Arhan and Arham. And you know that it has been stacked upon one upon another. So consider now that you have got a hollow cylinder. Both the sides are open, both the mouths are open. So meaning that we don't need to calculate the area of the base here. Okay, so you are left with only this, that is the circumference. So it's 2 pi r. Okay, so it has been stacked upon one another all the way up to here. So this is the component height over here. So 2 pi r multiplied height, right? So for example, you have got one circle over here. Okay, then you have got two circle over here. For example, you have got 10 circles stacked upon stacked one upon each other, and the circumference of one circle is, let's say, 5. Okay, so the total surface, so the lateral surface area or the curved surface area is going to be 5 multiplied 10. That gives you 50 centimeters square. Then what about the total surface area? So in total surface area, exactly, in total surface area, we count the area of the bases and top as well. Getting it?
Yes, so the perimeter, the circumference will be 2 pi r, and then we add the radius and the height, which is
Hmm.
r plus h.
So it will be first, you will take the area of the curved surface here, this curved surface area, right? That is how much, Arhan? That is 2 pi r h over here, no?
Yes.
Getting it? And now see, you have got two circles over here as well, pi r square plus pi r square,
Yes.
right? So 2 pi rh plus 2 pi r square. Getting it? So you take the 2s common over here, and pi and r are also common here.
Yes.
So here would be h plus r. Is that clear to both of you?
Yes. Yes.
So that's how we are supposed to find the total surface area of a cuboid. Getting it? Okay.
Yes.
So we have discussed about cuboid, cube, and this cylinder as well. Okay. One more thing. What if you will have to have a prism, and someone asks you to find the area of a prism? Yeah.
We will add the area of a triangle and a rectangle, so it
Yeah.
will be half a breadth
Hmm.
into height, and we will add the perimeter of a rectangle, which is 2 into length plus breadth.
Okay, look, let's actually discuss this one. Okay, let me erase this here. So you have got a prism. So the prism looks something like this, right? Okay. How many lateral faces are here, Arhan? How many lateral faces are here?
So 5.
No, lateral faces, excluding the top, front, and the back face here. There are 3 only, no? So if you were to find the lateral surface area. Okay, by the way, do we need to explain the prism? Huh? It's a it's basically a figure combined by joining 3 parallelograms or 3 squares or 3 rectangles. Getting it?
Yes.
Okay. That basically forms a prism. Okay, and if you close the top and bottom of the figure, then you actually get a prism, right?
Yes.
Okay, can you guys explain to me what is the application of this prism? Where do we use it in scientific experiments?
So to depict the rainbows, to depict colors.
Exactly, to get the spectrum, right? So if a white light passes through it, okay,
7 colors.
exactly, since the white light passes through it, it will start to
Refract.
sorry about that, it will start to refract. Okay, it will start to refract, and you will get a display of 7 colors on a wall.
Yes.
So that display of 7 colors is called as spectrum.
Yes.
So there we see a spectrum. Now coming back to here, lateral surface area we were talking about. So lateral surface area, how we are going to calculate? It will simply what? Perimeter of the base here.
Yes.
Multiplied height.
Yes, sir.
Yes.
So perimeter of base multiplied height. So that's how you're getting the lateral surface area. Now, next thing, what if you were to calculate the total surface area? Mhm.
I don't know.
Total surface area. It will be simply lateral surface area plus plus area of the end surfaces now. This surface over here
Yes, sir.
and this surface over here. Just calculate them. Plus 2 multiplied area of end surfaces. So area of end surfaces, how do you calculate them? Simply it's going to be half into base into height now,
Yes.
isn't it? So it's length lateral surface area plus 2 into half into base into height. So you get it lateral surface
Yes.
area plus breadth into height. Okay, so that is the required formula. In fact, I think you guys don't have to solve questions based on prism, but still we get to understand this one as well. Okay, then what
Yes.
if you were to find the volume? Arhan, how do you find the volume? Yeah, how do you calculate the volume of a prism? Yes, basically you take the area of base. Okay, and then multiply it with its height. Getting it over here. So that's how you can get the volume of
So
the
it is
prism.
half b into breadth into height square.
Whatever the area of the base is going to be, let's say it's length into breadth. Okay, then area then into height, right? So that is it. That's how we
Okay.
calculate it. Okay, and here we are especially talking about the right prism. So remember that point. Getting it?
Yes.
All right. Now moving on, you have got other examples of other examples also. For example, you have got a right angle pyramid in which one of the angle is right angled, right? Not one of the angle is right angle. Actually, you can draw a perpendicular line from the vertex to the opposite base. Look at the figure what I'm talking about here. So you have got right pyramid. So suppose you have got pyramid like this. Okay, excuse my drawing. It might not be very neat. Okay, let's say that is a pyramid over here. And this vertex from the opposite vertex, you can draw a perpendicular line to the base, to this opposite face over here. That is actually 90-degree over here. So that is a right angle pyramid. Now, if we were required to find the lateral surface area of this, so how do you calculate the lateral surface area? You will basically look out for the what?
The area of a triangle multiplied by 4.
There's one more
Multiplied by
component.
3.
There's one more component actually, guys, here. Okay, look at this height over here. This height. In case of a pyramid, you don't have a perpendicular height. Okay, if you were to calculate the height, it is quite difficult to calculate it perpendicular because the figure is not straight, right? The basically the edge is tilted. All the edges are tilted together. Okay, and joined at this vertex over here. So the height is rather than being perpendicular, it is tilted, and we call it as slant height. Right. So slant height is also there. Remember this thing over here. Now, in order to calculate the lateral surface area, the required formula is half into perimeter of base. Perimeter of base.
Perimeter of triangle, right?
Perimeter of this base over here. This figure over here.
Yes.
Okay. Multiplied slant height. Right. So that's how you are required to calculate it over here. Getting it?
Yes.
Okay. Any confusions to you guys so far?
No.
No, sir.
Okay. So differentiate between the convex polygon and the concave polygon.
So what?
Differentiate between the concave and convex polyhedron. Concave and the convex polyhedron. We talked about them, no? Like if the
The line, when we draw a line from one
Mhm.
vertex to the other vertex, the line
Hmm.
should be inside the figure.
If it is inside the figure, then it's a
It's convex.
convex polygon. Then if it's
Yes,
outside,
it's a non-convex or a concave polyhedron.
non-polyhedron simply, right? Okay.
Yes.
Getting it all right then. Okay. Now further, talking about the volume of the figure so far, we have discussed. How do you guys define the volume of the solid figures which we have been studying so far? Mhm.
The space inside a 3D figure.
Hmm. Basically, space occupied, right? Total space
Yes.
occupied by a
Hmm.
solid, right? Not especially
Yes.
inside, but outside as well, right?
Hmm.
Okay. Basically, you put it in a medium. Medium might be air, might be a liquid
Hmm.
medium. Whatever area is
Yes.
being acquired by it, that will be called as its volume, right?
Yes.
Okay. Out of solid, liquid, and gas, which one occupies the maximum volume?
A solid.
The solid.
Solids. No,
So
it's the
gaseous.
gas. It's the gas
Yes.
that occupies the maximum volume, right? Okay.
Hmm.
Now talking about the solids, few more things in the solids you guys can see. Okay. Like solids can be regular and solids can be irregular as well. Getting it?
Yes. Hmm.
Okay. And based on the number of edges, we have got different solids. For example,
Hmm.
uh, the minimum number of possible sides in a 2D shape, it is 3. So the
Yes.
figure is called triangle.
Triangle.
Okay, 3 angles, try 3 angles. Getting it?
Hmm.
Now, if it were to have 4, you call it as quadrilateral.
Quadrilateral. Yeah.
Yes, sir.
Then 5, what do we call that?
The
Polygon.
pentagon.
Pentagon.
Oh.
Polygon. No, polygon is actually a 2D polygon, 2D figure in which the number of
Hmm.
sides are more than 3. 3 or more than 3.
Okay. Hmm.
That is polygon. Okay, now moving on and on. If you were to have 6 sides, 7
Hexagon.
sides, 8, 9. Okay.
Septagon.
Yeah.
Hmm.
Hexagon. Okay. Heptagon.
Septagon.
Yeah. Then octagon.
Yes, sir.
Nonagon. Right. Then you have got
Decagon.
decagon. Getting it here. Okay.
Hmm.
So talking about the interior and exterior angles, right? For example,
Hmm.
if you to take one of the polygon out of here, for example, take this hexagon here. Okay. So
Yes.
in geometry, we see that hexagon is a polygon with 6 sides in which sum of all the interior angle is equal to 720 degree. Okay.
Hmm.
So talking about this hexagon, you see sum of interior angles
720.
720 degree. Getting it?
Yes.
Now, if look
Hmm.
at this triangle, what is the sum of all angles? Interior angles.
180.
Obviously 180. Then you
Yes.
will to have a quadrilateral. What is the sum of interior angle going to be? 360 degree now.
Sir, 360.
Getting it?
Hmm.
So you can see the measurement of the interior angles is varying, but based upon what? Hmm? Here, if you were to have 3 sides, the sum of interior angle is 180. If you were to have 4,
Yes, sir.
it's going to be 360. Then 6,
It depends on
720.
angles.
It depends upon what?
Angles.
Angles. Okay, look over here.
So it depends upon side.
Let's take a figure over here. This is a pentagon now,
Hmm.
right? So if you were to see a pentagon, we can actually draw the sides further like this. Okay. And these are the interior angles given for the figure. Now, if you were to see this angle over here and this angle, both of them are 90°.
Yes.
Yeah. Okay. Now, one way of finding it, you can simply do the geometrical construction here and you can get your answer. Like you can draw a line over here. This will be 90, this will be 90. Getting it here. So the it will be 360° here, right? Okay. And this, how do you calculate these three angles? Yeah.
I don't know.
Look, if this one is 90 and you draw a straight angle, this one is also going to be 90. This whole angle is also going to be 90°. The only possible way in which you can find the angles here, if this were to be an isosceles triangle, if the two sides were equal, then these angles must have been equal. Okay.
Yes.
So it's 45, it's 45, right? And this one would have been 90. Okay, but
Yes.
that's a given case in which you can find it out if the triangle was to be a isosceles triangle. Okay, now moving on. What about the number of sides in a heptagon? How many sides are there? Yeah,
7.
7. So how do you
Yes.
find this interior angles in this one? Arhan, can you recall? We have in fact discussed this in the chapter quadrilaterals. Yeah. Although this is not part of the current chapter, I mean, no need to discuss this in this ongoing chapter. But how do you calculate the exterior angles, interior angles? Huh? Yes, Arhan. I'm directing this question to you since you have already studied this chapter. Mm-hmm.
So we
Remember?
can find.
Mm-hmm. Yeah, we can find what?
So we can find exterior angle by
What?
uh, n minus. We can find exterior angle by n minus 2 multiplied by 180.
N minus 2 multiplied 180. Okay, so let's see if what you are saying, if we can do this further. Okay, so suppose, and in the case of heptagon, it's obviously 7. 7 minus 2 multiplied 180, right? So 5
Yes.
into 180, you get 900°. So is it possible to get an exterior angle that is equal to 900°?
No.
No, obviously no, no. So the
Yes.
formula which you are saying here, it is actually the formula required to find the interior angle. We can use this one. Getting it over here. Okay. Similarly, if you were to have an octagon, there the number of sides is 8 here. So here the sum of all interior angles, it is going to be 8 minus 2 into 180. That is 1080°. Okay. Okay. So from here on, we will continue our discussion further in the next class then. Okay.
Yeah.
Okay. For the time being, revise whatever we have discussed in the chapter and try to solve the first exercise. Okay. So
Yes.
one of you guys, please do tell me what is the first question of the exercise, because I don't have got the PDF right now. Basically, you guys will be required to find out about the figure. Like the question might be like, I didn't know what the side view is going to be like, what the top view is going to be like.
Sir, it is first question is for each of the given solid, the two views are given. Match for each solid that the corresponding top and front views. The first one is done for you. So there are
Okay,
almost
okay. So that will be pretty
15
easy.
figures.
That will be
Yes.
pretty easy now, guys. Just have to identify the side view and the top view. Right. Okay. And the next
Yes.
question, what does it says?
For each of the given solid, the three views are given. Identify for each solid the corresponding top, front, and side views.
Okay,
It's also the same.
that is also same. Okay, so for example, if the figure is like this, let's say, right? Okay, like this here.
So what was the question again?
The next question which Aram was reading. Okay. Suppose the figure is like this.
Is it for each of the given solid the three views are given? Identify for each
Yes.
solid the
Okay,
Yes.
okay, yeah, the same which Aram was mentioning. Okay, so if you
Okay,
were to
sir.
find, if you were to represent it on a piece of paper, let's say this is a
Hmm?
given figure over here, right? So first see the front, top, and side views. So from the front side, this is going to be looking like this. This is the
Hmm.
front side now. This is the top
Yes.
side. Okay, and this here, this one
Side
here will give you the front view.
side view.
This one
Side
is
view.
front view. This one is actually side view. Yeah, this one,
Yes.
this face gives you side view. So if you were to represent side view, how do you represent side view? For this figure, how the side view is going to look like? It will be simply like this now,
Yeah, rectangle.
right? 3 divisions in a
Hmm.
rectangle. Okay. Now,
Yes.
if you were to draw a front view, so which one is going to be the front view? This one, now guys.
Yes, sir.
So it's going to be like this over here. Getting it? Okay. What about the top view?
Yes, sir.
What about the top
So
view?
it will be
Or if you were to look at this 3D figure from top, you will be able to see this one and just this one only.
yes, sir. Yes, sir.
So it will be like this. Hello?
Yes, sir.
Okay. Okay. So that's it for today. We will meet in next class then. So complete the first exercise. That's